Hello learners. Let me ask you something fun. What's the difference between getting hit by a cricket ball and a table tennis ball? Both are small, both are round, but only one sends you running for first aid. The difference is explained by Newton's second law of motion. An object changes its velocity only when an unbalanced force acts on it. The larger the force, the greater the change in speed or direction. That's why a fast-moving bullet, though tiny, can be more dangerous than a stationary truck. In words, if the net force is not equal to zero, the velocity changes. To explain this better, physics introduces a new quantity, momentum. Momentum is equal to mass multiplied by velocity. In words, P equals m times v, where P stands for momentum, m is the mass measured in kilograms, and v is the velocity measured in meters per second. Momentum is a vector, which means it has both size and direction. That's why a moving car has much larger momentum than a cycle, even if both move at the same speed. Momentum measures how difficult it is to stop an object. Newton's second law says the force on a body is equal to the rate of change of momentum, and it acts in the direction of that change. The formula is force equals change in momentum divided by change in time. In words, F equals delta P divided by delta T. This means that if you apply a larger force or apply the force in a shorter time, the change in momentum will be greater. That's why when a cricket bat hits the ball, in just a fraction of a second the momentum changes drastically, producing a big effect. Let's derive this step by step. Suppose a body has mass m, initial velocity u, and final velocity v in time t. Change in momentum equals mass multiplied by the change in velocity. That is m times open bracket v minus u close bracket. Divide by time, force equals m times v minus u divided by t. Now, v minus u divided by t is acceleration, denoted by a. So the formula simplifies to force equals m times a. In words, force equals mass multiplied by acceleration. Now, let's see how this law works in real life. When a fielder catches a cricket ball, he moves his hands backward. Why? Because increasing the time of contact reduces the force on his hands. When a high jumper lands on sand or a cushioned mat, the stopping time is increased and the impact force is reduced. On the other hand, in karate, a chop is effective because the contact time is extremely short, so the force generated is very large. In words, force equals change in momentum divided by time. Longer time means smaller force, shorter time means bigger force. Let's solve a numerical example. A body of mass 5 kilograms changes its velocity from 3 meters per second to 7 meters per second in 2 seconds. Find the force. Step 1. Force equals mass multiplied by change in velocity divided by time. Substitute the values. Force equals 5 multiplied by open bracket 7 minus 3 close bracket divided by 2. That is 5 multiplied by 4 divided by 2. The result is 10 newtons. Now, if the same force continues to act for 5 seconds, what will be the final velocity? Final velocity equals initial velocity plus force multiplied by time divided by mass. Substitute 3 plus open bracket 10 multiplied by 5 close bracket divided by 5. That is 3 plus 10. The final velocity is 13 meters per second. Let's wrap it up. Newton's second law connects force with momentum. In words, force equals mass multiplied by acceleration, and force multiplied by time equals change in momentum. It also gives the definition of 1 Newton, the force required to accelerate 1 kilogram of mass by 1 meter per second squared. This law explains airbags, cushions, soft landings, and the technique of catching a ball. All of these work by increasing the time of contact and reducing the force felt. So to sum up, force doesn't just push or pull, it measures how fast momentum changes. And the faster the change, the greater the force. I hope you're now confident enough to explain this law, not only why catching a ball needs soft hands, but also why airbags and seat belts save lives. See you in the next session where we'll uncover Newton's third law, the law of action and reaction.